Today we will study about electrophilic aromatic substitution reactions. After going through these slides, students should be able to give the example of electrophilic substitution reactions and describe the general mechanism of electrophilic aromatic substitution reaction. These are the learning outcomes. Now we know that the characteristic reaction of benzene involves substitution, in which the resonance stabilized ring system is preserved. So what kind of reagents bring about these substitution? What is the mechanism by which these reactions take place? We will study under this topic. Unlike aliphatic system, electrophilic substitution reactions are common in aromatic compounds. All the common well-known substitution reactions are nitration, sulfonation, halogenation, Friedel-Crafts alkylation as well as acylation, protonation, diazocoupling, nitrosation, Kolbe reaction, Reimer-Tiemann reaction. So these all are the electrophilic substitution reaction which are common in aromatic compound. Now the experimental evidences indicate that all the electrophilic substitution reactions of aromatic hydrocarbon proceed by common mechanism. Therefore, we will first deal the mechanism in general and then apply it to specific substitution reactions like nitration, halogenation, sulfonation, etc. So now we will discuss the general mechanism. The electrophilic aromatic substitution reaction take place in a two-step. First step, this is the slow step which is also known as the red determining step. In the first step, the electrophilic reagents attack on the pi electrons of the aromatic ring to form an intermediate which is known as aronium cation, the sigma complex or the pentadienyl cation. Pentadienyl cation means since the intermediate has no longer a benzene structure but an unstable cation with the 4 electrons delocalized over the 5 carbon nuclei. That is why it is known as the pentadienyl cation. Because the 6th carbon atom is a saturated carbon and form the sp3 hybridized bond. You can see in the first step, look at the diagram, look at the mechanism. It clearly shows that electrophilic attack on the aromatic ring and it will form an intermediate which is known as aronium cation and pentadienyl cation or sigma complex. So as I told you, you can see that the intermediate no longer a benzene structure but unstable cation with the 4 pi electron delocalized over the 5 carbon. You can see clearly. That is why it is known as the pentadienyl cation. Now we will talk about the step second. Now in step second of the reaction involves the elimination of a proton from the intermediate by an anionic species to form a substituted aromatic compound. So in the second step, the reaction involves the elimination of proton. You can see clearly in the second step, which is also known as the proton loss. Okay, so this is the general mechanism of the electrophilic substitution reaction, and thus the electrophilic aromatic substitution reactions are bimolecular since the red determining step involves 2 molecules and the second step will be fast step. So thank you so much. We will study in our next slides about the particular or the specific substitution reactions like nitration, halogenation and sulfonation and many more. So again, thank you so much.